ENCOR Section 18 Summary Challenge. Understanding wireless client authentication. Which three statements correctly describe wireless PSK authentication? Okay, PSK is pre-shared key. It uses a common key between the client and the AP for authentication and encryption. This is correct. It provides a base layer of security for large enterprise networks. Probably not. It's not very practical to use pre-shared key in large enterprise networks. Keys will have to be deployed on client devices that use this wireless LAN. Well, yes, deployed means pretty much you just need to type it, like you would type a password. If that counts as deployment, I guess that's the correct option too. If you no longer want a client to have access, keys must be changed for the access point and all the other clients. This is correct. Because this pre-shared key, it's not only shared between access point and the client, but it is just one key for everyone, all other clients included. So if you don't want someone to continue be able to use the network, you would have to change the key, the password for the whole network, and which means that all clients will need to be changed. Will need to change the key as well. Keys will have to be deployed on all client devices on all wireless LANs. Okay, so I see this maybe. These two options are related. Let me take a closer look at them. Keys will have to be deployed on client devices that use this wireless LAN. Okay. Keys will have to be deployed on all client devices on all wireless LANs. Well, one thing which is for sure, you can have different authentications for different wireless LANs, right? Even if these wireless LANs, they live in the same infrastructure, the same wireless controller, you can create wireless LANs and they may have different authentications. So one could be PSK, another could be something different, right? So I guess then this option is better than this one because needs to be deployed on all client devices, on all wireless LANs. This is not correct. You only need to deploy the key on client devices which belong to the only wireless LAN which you configured PSK for. And the final option is PSK is a widely used authentication method for enterprises. This is not correct. PSK is typically for small offices or for homes. Place the steps of a successful wireless 802.1x authentication in order. Okay, so let's see what's happening first. We have 5 steps overall. Access request is sent to radio server. Supplicant sends the association request. Okay, I think this one is the first step here. Supplicant, which is the client, sends an association request. So before that, actually, what wireless client does is it connects with the open authentication, right? But because 802.1x blocks data traffic until the proper authentication is done later on, this client will not be able to use the network, right? And this authentication process, the proper authentication process, starts after the association is done. Okay, radio server sends. Okay, access request is sent to radio server. Authenticator sends access success to supplicant. I think this is the next step. So what access point or wireless controller does, it sends the access request to the radio server. Well, probably this should be a bit later because supplicant provides login credentials. And then access request is sent to the radio server. There we go. And then radio server sends access success in case of successful authentication to authenticator. And authenticator, again, this is either access point or wireless controller. And then authenticator sends access success to supplicant, right? So basically in all this conversation, the authenticator, which is the AP or WILSI, it serves like a middleman. It just kind of transfers the traffic between the client and the server. Which statement best describes public key infrastructure? Public key infrastructure is the trusted third-party entity that signs public keys in a network. This is actually CA, Certificate Authority. So this is not a valid option. PKI is the document that binds names to public keys that are signed by the CA. This is not a document. This is infrastructure or a framework. PKI is a service framework that is needed to support large-scale public key-based technologies. I think this is a good option, a very good definition of PKI. Let's check the other one just in case. PKI is a well-known standard that defines the format of a digital certificate and CRL, I'm not even sure what CRL stands for, to enable basic interoperability. No, it's not a standard. It's just a general term, right? Like a framework. It doesn't define specifics of how protocols and how protocols work and how certificates are formatted. Okay. Which three statements correctly describe asymmetric encryption? Okay, that should be easy. One private key can be used to decrypt content encrypted by multiple public keys. This is not correct. There is always just one pair of keys. So one public key and one private key. It is not possible to have one private key with multiple of public keys. I'm now thinking, could this be mathematically possible? Maybe. This would be interesting. But I have never heard of anything like that existing and being used. So it's always just pair, right? One public key and one private key. Public keys can be shared with anyone. This is correct. Private keys are unique to a single entity. Well, yes, I think if we are a client, let's say, is an entity, we generate the key pair, which is public key plus private key, and this private key will be unique for us as an entity. So that looks like a good option. Public keys must have a modular size of 1024 or lower. No, this is not correct. It can be even higher. No problem with that. A CA verifies a public key's owner, and this is correct, right? So with asymmetric encryption, the first step is typically the exchange of the public keys between the parties, right? And then each party, each side basically encrypts traffic which it sends with the public key of the other side, right? So the other side, when it receives the traffic, is able to decrypt it with its private key. In the beginning of this process, as I said, there is exchange of the public keys, and one concern from the security standpoint is, are these public keys really legit? Are they actually coming from whoever claims them to be coming from? So, and that's where the trusted third party comes in as a certificate authority, and it basically signs those public keys and makes sure they are valid. CA uses a digital signature to sign the owner's private key. No, this is not correct. CA would never know the owner's private key, right? What is the main advantage of EEP fast over EEP TLS and PEEP? Okay, so EEP fast is the one which uses the PAC, PAC, PAC stands for provisioned or protected credential, protected authentication credential, I think, instead of using certificates, right? So it provides mutual authentication client to server and server to client. I think this is one advantage of EEP TLS. It provides a higher level of Wi-Fi security. Well, yeah, I guess it does. But let's see others. Neither the client nor the server require a certificate. I think this is the particular thing which distinguishes EEP fast from two other methods. PEEP does not necessarily require a certificate. I think for server it's optional, but EEP fast basically certificates are replaced with these PACs, and there is no need for certificate. And this still provides a very, very great level of security comparable with EEP TLS, which, by the way, also uses certificates on both sides. Both client and server need a certificate. Okay, what are 3 requirements for EEP TLS? Authenticator certificate, client-side certificate. Yes, please. So client needs a certificate. Server needs a certificate. Authenticator does not need a certificate. It's just a middleman which helps the transactions. LEAP capable client. No, LEAP is completely different EEP method. Supported radius server, a pre-shared key on the server. So is it radius? So it's either, okay, does it use radius? Does it need to use radius? I'm just trying to recall how EEP TLS works. I don't think there is a need for radius server. The pre-shared key on the server. No, there is no need for pre-shared key either, right? Okay, I'm just not sure about this one. There are 3 options. Supported radius server. Does it need a radius server? I think it does, right? Because it needs to have, it needs to identify clients, right? And these clients need to be uniquely identified, and that's where the user accounts kind of come in, and this is provided by a radius server. I'm not quite sure. I do not recall like particular radius steps in the EEP TLS process, but I guess it's there somehow, right? Yeah. Well, there is no definitely pre-shared key is something nonsense, I guess. A pre-shared key on the server. No, we do not need a pre-shared key on the server, right? Okay. I'll keep it this way. How is the client authenticated with PEEP? Okay, so the PEEP uses it relies on CHAP or other kind of protocol, and this protocol, or it relies on CHAP, or there is one more, which is GTC, generic cards, token cards, right? GTC is something like generic or general token cards, GTC, and both of these authentication mechanisms, they rely on username and password. Okay, which 3 options must be defined for web authentication? Okay, where web portal pages are being provisioned from? Yes, so there are options, right? This could be done by the WILSI wireless controller can serve these web pages, the Splash web portal, or it can be provided by a Cisco ICE. where the users are physically located. Doesn't matter actually where they are as long as they can connect to the wireless network. So this is not a good option. Where guest path isolation is defined in the network. This is also a good option because there are a couple possibilities, right? If it's a local web authentication just on one and only WLC, this WLC will define the path isolation. So basically it will take the SSID traffic from the guest wireless LAN and map it into the wired virtual LAN, right? Or it could be done on so-called anchored authentication, anchored. Forgot the proper naming, but it's something related to Anchor, right? It could be a dedicated WLC in our kind of wireless network support infrastructure, and this WLC will play the role of kind of terminating all wireless guest SSID traffic and converting it into the wired traffic and releasing it into the wired network, typically located in the DMZ. Okay, times of day when guest users, Quest users somehow, but who knows, they're possible, Quest users could also exist, are allowed access. Well, no, this is not the definition, right? Guest password, no, the guests would not use just single password, I guess. Where users are being provisioned for, yes. So guest users will have their own accounts, like usernames and passwords, individual, right? And these user records can also be stored in different locations. It could be either WLC or could be a radio server, and this radio server could also happen to be the Cisco ISE, Identity Services Engine. You have been tasked with providing a design for guest access for a large corporation. You have decided to use an anchor, WLC. Where in the network will you place the anchor? And as I have explained the previous question I was just mentioning, DMZ, demilitarized zone, is a good place to put this anchor WLC. All right.